Through this course, an introduction to heat exchanger, we hope to help our new colleague understand the company's products in the shortest possible time. The course is divided into 4 chapters. 1. What is a heat exchanger? 2. How to name FFC's products. 3. How does a heat exchanger work? 4. Some industrial applications. Section 1. What is a heat exchanger? In fact, the heat exchanger is not an unfamiliar product. It appears in our daily life. The picture on the left-hand side is a radiator for a car, and that on the right-hand side is a window-type air conditioner. The red boxes in the pictures show where the heat exchanger are located. Put it in a simple way, a heat exchanger is an equipment that exchanges heat. Heat is an intangible physical quantity. An indicator temperature is used to measure the amount of heat contained in an object. Thus, to be more precise, a heat exchanger is a device that provides heat exchange between two or more gases or liquids with different temperatures. Heat exchanger has two main components: working fluid and heat transfer surface. Refer to the figure. Inside the heat exchanger, the heat transfer surface is carefully designed. Two fluids with different temperatures exchange heat across this heat transfer surface. After the heat flows to the cold fluid, the temperature of the hot fluid decreases, and that of the cold fluid increases. The term fluid includes both gases and liquids. They have no particular shape and can deform depending on the shape of the container. They can undergo continuous deformation when subjected to shear stress. Working fluid. Working fluid refers to the two fluid streams at different temperature levels in the heat exchanger, which the heat transfer process occurs between them. In normal use, the working fluids could be gaseous, like air, flue gas, and steam, and liquid fluids are water, refrigerant, and fuel oil. Here, special attention should be paid to flue gas. This type of working fluid is the exhaust gas from a combustion process and then discharged into the atmosphere via stack. Later, we will discuss it in more details in the section of heat recovery applications. Heat transfer surface. Heat transfer surface is an impervious surface. Through it, the heat is transferred from the hot fluid to the cold fluid. The term impervious is an adjective and means the surface does not allow material to go through. Bare tube, regenerative material, thin metal plate, thin tube. All these objects can be used as heat transfer surface. Bare tube. A cylindrical hollow object. The material is not limited to metal. According to the needs of the usage, they can be Teflon, glass, and other materials. Regenerative material. A poroceramic material with unique appearance that can store heat energy. Thin metal plate. A metal plate with a special pattern. Thin tube. On the outside of the bare tube, an outward metal strip is added by various processing methods. We make a session summary. All FFC's products are tubular heat exchangers. They use either bare or thin tubes at the heat transfer surface. During heat transfer, the heat exchanging fluids are not in contact. Section 2. How to name FFC's products. FFC's products include tubular heat exchangers and several types of thin tubes. Regarding heat exchangers, they are classified into two applications: industrial applications and waste heat recovery applications. They are named after the cooling media to be used or their usage purposes. For industrial applications, 5 types of heat exchange equipment are available to fit the requirements of different manufacturing processes, including air-cooled condenser, air cooler, steam air heater, water cooler, and shell and tube heat exchanger. Those inside the blanket are their respective abbreviation. Air-cooled condenser. An air-cooled condenser is a cooling system where the steam being discharged from the steam turbine is cooled by ambient air. The working fluids are steam and air. The heat transfer surface is fin tubes. The tube side is the inside of the heat exchange tube, and the shell side is the outside of the heat exchange tube. Steam flows through the tubes and air flows outside the tubes. Such a system is installed to recycle the steam by condensing it into liquid water, especially used in regions that lack cooling water. During the cooling process, the heat of steam is removed by air. Steam will go through a phase change into water called condensate. The drawing shows the air-cooled condenser in 3 views: top, front, and side view. Viewed from the side, it looks like the letter A. Hence, we name it an A-frame type air-cooled condenser. It consists of an array of bundles placed on an A-shaped structure. People may ask, why the bundles are placed at an angle to the horizon? The reason is to reduce the occupied area of the heat exchanger. To enhance its effectiveness, the heat transfer area is designed as large as possible. We arrange the heat bundles at an inclined angle to the horizon in order to keep the occupied area of the heat exchanger small. This typical setup for an air-cooled condenser includes 5 parts. 1. Steam duct, a pipe designed to carry exhaust steam from a turbine to ACC. 2. Tube bundles, arranged in a parallel row, a collection of fin tubes where heat exchange takes place. 3. Condensate pipe, pipes designed to return the condensate to the drain tank. 4. Fan and transmission system, consists of a fan, motor, and speed reducer, generating an axial flow to force cooling air across tube bundles. 5. Support structure. Air cooler. An air cooler is a cooling system where the process fluid is cooled by ambient air. The working fluids are process fluid and air. The heat transfer surface is fin tubes. Such a system is installed to cool down the process fluid to a required temperature, especially used in regions which are lack of water. During the cooling process, 2 situations might arise. 1. The working fluid changes in temperature only. It means that the hot fluid is cooled down from a high temperature to a lower temperature, and there is no phase change in the hot fluid. 2. Phase change occurs in the hot fluid after being cooled by air. The hot fluid, which was in the gaseous state, condenses and turns into a liquid state. An air cooler consists of the following components: tube bundles, fan and transmission unit, header walkway, connection walkway, ladder for header walkway, steel structure, motor for maintenance walkway, loop of process outlet temperature control. Furthermore, according to the arrangement of the cooling fans below or above tube bundles, there are 2 types of air coolers: forced draft and induced draft. Forced draft air cooler is the most common type of air cooler. The fans are designed beneath the tube bundles, allowing easy maintenance to all mechanical components. Induced draft air cooler has the fan located above the bundles and the ambient air is pulled across the tube surface. Compared with the forced draft air cooler, the induced draft design provides better air distribution across bundles and protects tube bundles against different weather conditions, sun, rain, and hail. However, when the temperature of the discharge airstream is higher than 95 degrees Celsius, forced draft designs should be considered. This is because the high temperature air out of bundles may cause potential damage to fan brace bearings and other components which are in the path of the airstream. Steam coil air heater. A steam coil heater is a type of preheater in which condensing steams transfer thermal energy to air. The working fluids are steam and air. The heat transfer surface is bare or thin tube. Such a system is installed to preheat air to a required temperature. Steam. It is a gaseous water formed after heating liquid water to boil. What is the difference between superheated steam and saturated steam? Under constant pressure, water is heated to its boiling point and then continues to heat, and then water begins to evaporate into steam. That is, a phase change occurs. At this moment, both the temperature and pressure are unchanged. A mixture of steam and liquid water exists. The steam at this time is called saturated steam. Finally, all the water is vaporized into water vapor, and the water vapor no longer contains any liquid water, which is called dry saturated steam. If the dry saturated steam is heated further, and its temperature will rise again, and exceeds the boiling point at this pressure, then the steam is described as superheated. Here, a top view and side view of two-stage steam air heater are shown. In order to increase the air to a higher outlet temperature, a two-stage heating is used. Meanwhile, both low pressure and high pressure steam are introduced to heat the air in the same heat exchanger. The picture shows a steam air heater with an inlet and outlet hood. The inlet or outlet hood is the passage that conveys the heated gas into or out of the steam air heater. A tube bundle is a collection of bare or thin tubes where the heat exchange takes place. Depending on the requirements of customers, they can be placed vertically or horizontally. Water cooler. A water cooler is designed to circulate water and keep the temperature of dry or damp air at or near a low temperature or relative humidity. In general, the working fluids are water and air. The heat transfer surface is thin tubes. Air is kept on the shell side and water is on the tube side. Water coolers, mostly designed in square shape. At the corner of the casing, stress will concentrate. The thickness of the steel plate should be increased at the corner in order to let it strong enough. Hence, as the operating pressure in the shell side is high, the casing of a cylindrical shape is selected for cost consideration. In such a way, the thickness of steel shell can be reduced. The figures show the final design of water cooler products. Shell and tube heat exchanger. A shell and tube exchanger consists of a number of tubes mounted inside a cylindrical shell. It is a simple structure, easy manufacturing and low production cost. Moreover, it is reliable under different operation conditions. Compared to other types of heat exchangers, it is widely used in the chemical processing plants for transferring heat between two fluids at different temperatures. These figures illustrate some typical units that may be found in a chemical plant. Fixed tubes means the ends of each tube are connected to tube sheets. The tubes may be straight or belt in the shape of the letter U, which is called U-tubes. Diagrams showing the internal structure of fixed tube and U-tube heat exchanger. For waste heat recovery applications, flue gas is the exhaust gas from a combustion process. It contains useful energy and is valuable for heat recovery. According to the temperature, it is classified as high, medium, and low temperature grades. High temperature waste heat recovery system consists of recovering waste heat at temperature greater than 600 degrees. The medium temperature range is 200 to 600 degrees, and the low temperature range is for temperature below 200 degrees. Waste heat recovery systems are introduced for each range of waste heat to obtain the optimum efficiency of waste heat recovery. For example, it can be fed into a gas turbine to generate electricity or into a heat exchanger to preheat a cold fluid. There are three different kinds of heat recovery heat exchangers: air preheater, economizer, and waste heat boiler. English alphabet inside the bracket is its respective abbreviation. Air preheater. An air preheater is installed to preheat the process gas or prevent the occurrence of the white plume at the stack. The cold fluids are flue gas or air. The heat transfer surface is bare tubes. Two types of air preheaters are shown. One is air on the tube side, and the other is air on the shell side. This is the final product side of an air heater and its corresponding side view drawings. Economizer. Economizer is from the etymology economy. Economizers are heat exchangers which save energy by using flue gas to preheat a cold liquid. The heat transfer surface is the bare or thin tubes. Economizers mostly have square-shaped design. In addition, they are usually designed in multi-pass, straight pipes with elbows, to increase the time of heat exchange between hot and cold fluids. Waste heat boiler. Waste heat boilers are heat exchangers which utilize the heat in the flue gas to generate saturated steam. The heat surface is the bare or thin tubes. These are the three views of a fourth type of waste heat boiler. The hot flue gas is from an air pollution control equipment called Regenerative Thermal Oxidizer (RTO), in which volatile organic compound emissions generated during industrial processes are decomposed. The picture shows the heat is recovered from the flue gas to produce steam before it is discharged to the environment through the stack. Furthermore, a bypass loop is installed to allow for continuous operations of the system while the waste heat boiler is undergoing maintenance. Fin tubes. Fin tubes are made by attaching fins to the outer surface of a base tube, which increase the surface of the tube and enhance its heat transfer performance. 4 types of fin tubes can be produced in a factory. The L, LL, and K-type configuration refers to the shape of the fins on the tube. As viewed from the side, L-type fins look like the letter L, while LL-type fins have double L structure with a groove in the center to improve the bonding strength between the fins and the base tube. K-type fins are similar to the L-type fins but have a narrow surface to increase the contact area between the fins and the base tube. For I or G-type fins, the fin strip is wound into a machine groove and securely locked into place by backfilling with base tube material. The further down the fin type, the higher the allowable operating temperature, because the stronger the bond between the fins and the tube. Section 3. How does a heat exchanger work? There are three modes of heat transfer: conduction, convection, and radiation. The temperature difference between working fluids is the driving force for heat transfer. Whenever there is temperature difference, the heat carried by the hot fluid is transported by convection and conduction to the tube and fin surface, and from there by convection into the cold fluid. In a fin tube, the heat carried by hot water is transferred by convection and conduction to the tube and fin surface, and from there by convection into the cold air. Similarly, in a bare tube, the heat carried by flue gas is transferred by convection and conduction to the tube surface, and from there by convection into the cold air. Section 4. Some industrial applications. Case 1. Waste incineration plant. A waste incineration plant is a waste management facility that combusts waste, produce electricity. Heat exchangers most commonly used in the plant are ACC, AC, SAH, S&T, and ECHO. This is a simplified flowchart of the water-steam cycle in water incineration plant. Boilers are facilities that boil water with the heat generated during waste incineration in order to produce steam. The produced steam is sent to a steam turbine and used for generating electricity. It is also distributed to other facilities to provide the source of heat for heating combustion air and feed water, or it is fed to the deaerator to remove oxygen and other dissolved gases from the feed water. Low pressure and low temperature steam exhaust from the turbine is completely condensed in the air-cooled condenser. Condensate from steam air heater and air-cooled condenser is mainly collected in a drain tank. In a feed water heater, recycled condensate is preheated by steam extracted from the turbine, and then oxygen is removed in the deaerator. Finally, condensate flows back to the boiler and is heated into steam. In the flow chart, only ACC, SH, and S&T are shown. In fact, AC should be installed to cool down the circulating cooling water, and ECHO should be used to further preheat the boiler water. ACC. This is our ACC system installed in Yokosuka, which uses 35-degree air to cool down low-pressure exhaust steam. Later, you may want to take some time to watch the attached site visit video to get a better idea of the ACC system. The video was filmed from location 1 to location 8. For the X, Y, double Y notation, X represents the position of the marked location, and Y, double Y, represents the corresponding time in the video. Starting at location 1, walk up the stairs to location 2, then open a door, which is the ACC platform. Walk counterclockwise to the back end of the platform. There is a door on A-frame structure. Open it and walk into the ACC's internal motor aisle. Directly down below, there are large cooling fans. B. AC. Air cooler is used to cool hot water by air. This is an air cooler installed in Kaohsiung, Taiwan, which uses 37-degree air to cool down hot water from 48 degrees to 44 degrees. C. SAH. A steam air heater is used to preheat combustion air to a required outlet temperature. This is a two-stage steam air heater installed in Keelung, Taiwan. Firstly, the air is preheated to 150 degrees using low-pressure steam, and then it is further heated to 205 degrees using high-pressure steam. D. S&T. A shell and tube heat exchanger is used to cool down the blow-off water from boiler. This is a blow-off cooler installed in Taidong, Taiwan. Water that is drained to help maintain the boiler water quality within the prescribed limits is called blow-off water. With the blow-off cooler, its outlet temperature is cooled down to 50 degrees before draining. Case 2. Water cooler. The water cooler is used to cool air to require low temperature. By using chilled water, the outlet temperature of the air is cooled to 20 degrees. In this case, the pressure of air is designed up to 1 kg per centimeter square in gauge. For the pressure on the shell side is very high, a cylindrical shell which uses a thinner thickness is chosen for cost reduction. Case 3. Air preheater. Air preheater is used to recover energy from hot exhaust gas of the paper dryer system. In order to fully recover the heat energy in the low temperature exhaust gas, the air preheater requires a large heat exchange surface. Case 4. Economizer. The flue gas discharge from a boiler is used to preheat the free water to a higher temperature with an economizer. The temperature of free water is increased from 110 degrees to 176 degrees. Case 5. Waste heat boiler. A waste heat boiler is used to recover high temperature waste heat from the exhaust gas and generate steam for thermal applications. This picture shows the waste heat boiler pre-installed in our factory. Under normal operation, the outlet temperature of flue gas is about 900 degrees. This is the end of this course. Hope you will have got a preliminary understanding of our company's products. Welcome to join us and wish you all the best in your career with our company.